Welcome, everyone. So today, this session is about how Cloud Code is built. So we are looking into what is under the hood behind the Cloud Code. And after I have got all the materials, I realized that really the true power of simplicity in the Cloud Code design in the agentic development process. Yeah, so some key highlights of Cloud Code. So I bet you have either hear about all the headlines about Cloud Code, the big news out there, or you may have already tried Cloud Code yourself, right? So Cloud Code is an AI coding assistant that can help you analyze the code, write codes, or debug, or even help refactor the codes, right, to clean the codes up through a command line interface. So do not expect it like very fancy, but it's like a very simple command line language interface. And since it's released last November, I think till now it's almost a year, it's rapidly adopted by developers worldwide for faster development. And it was also amazing to see that this product was initially built by a very small team of 2 engineers. So actually the prototype was built just by 2 engineers at Anthropic. And right now, I think they are expanding to just 10 engineers. So it's really interesting to see how in the era of AI agentic development, the small team can really make a big impact. And also they claim that the Cloud Code, the tool itself, wrote 80% of the codes using AI. So it's like 80% of the codes is written by Cloud Code itself. So it's very interesting to see that happening, right? Like a small team making a big impact with the tool they're actually developing. Like using the tool they're developing to develop the tool. It's kind of like a loop there. But I think it's like very impressive of how they can achieve this rapid adoption by just a small team of engineers. Okay, and then how Cloud Code is built. So I have watched their cloud engineer interviews and also reading their blogs. And then I summarize it into 1 core principle, 4 core strategies, 6 core designs. And then at last, I also want to share like how you can start with Cloud Code and what are the common workflows that how you can use the Cloud Code for your development. So let's start with 1 core principle and then 4 core strategies. Core principle, simple. 1 sentence, simplicity over complexity. The engineers specifically mentioned that they apply the Unix philosophy to AI development. And then the first philosophy in Unix, like the Unix designer, is the embrace of the simple approach, right? So they adopt this philosophy in design Cloud Code. For example, they designed in a very lightweight shell wrapper rather than a very fancy UI. And they directly give full access to the cloud model and the hood for the full capabilities of the model. And also they're trying to make the behavior of the agent transparent and also such as the costs, right? So they basically like embrace the transparent behavior, predictable performance, and also provide the full model access of the cloud model and the hood. Instead of if you compare the simple approach to complex approach, the complex approach is like you could design like multiple layers of abstractions, right? Which may make it straightforward for the user in some sense, but also the user may lose track of what is happening under the hood. And there may be like hidden optimization the user is fully not aware of, and also it's like a black box with unclear behavior. So in the core principle of how they design Cloud Code, they fully adopt the simple approach over the complex approach, which also makes sense, right? Because it's like it's initiated by 2 engineers, like, so you need to make sure that the design is to the core, to what is really useful and yet powerful. Okay, so yeah, principle, 1 word, simplicity. And then when they design the Cloud Code, so there are 4 strategies they use, right? I think the first strategy is just like any agentic AI development is the agentic workflow with the key functionality of explore, plan, and execute. right? So explore is because it's like a coding environment. So it allows the model to read the files and understand the directory structure of the files, and then identify the relevant files and the dependencies in your directory of the project. So that's the exploring part. And then the plan part is given the request, right? You need to think, you need to reason about what is the strategies to implement that out, consider the edge cases, and then outline what are the steps you want to execute. And then after all the prior two steps are done, then they start writing codes. It's not like, oh, this is a request, I will start writing code right away. They find that doing the exploration and planning beforehand will help the codes to be delivered in a better quality. Yeah. So this systematic approach ensures that the agent fully understand the environment, the use cases before the actual code implementations. Okay, and then the next strategy is also very interesting, is the task-driven development integration. So usually it's like you provide a request, right? So you provide a request to Claude Code, and then you will start with asking the agent to write a test for the feature you request. And then the codes may fail in the beginning, right? So you prioritize writing the failing tests in the beginning. And then after the tests are there, kind of keep it frozen, right? Do not ask the agent to modify the test. So keep the failing test frozen, and then ask the agent to write the codes iteratively until all the tests pass. Right? So the agent can kind of do the work on their own and then rerun the tests and observe the errors and trying to resolve the errors so that until all the tests can pass. And then it will come to a refactoring phase. The codes may be very verbose and maybe not in a very good architecture, right? And then you ask it to clean the codes in a cleaner format or in certain coding style. And then you basically just iterate this process by adding more failing tests to improve the code quality through this loop. So this is the test-driven development philosophy. And I think this is also will be a very powerful mental model when you use any coding agent. It's always like a test first, or else you don't know like whether the code works or not for your use cases. Okay, the third core strategy is conservative permission. Conservative permission is you don't want the agent to go wild, right? The code agent you design in such a way that you stay in control. So the user stay in control, and the user can define what files or what permissions the agent can have. Right? For example, over here, the user asks to create a test file in this directories, and then the agent will start some work. And then you say, oh, I'm going to create a new file in this directory. Do you want me to proceed? So basically in that interactive process, the agent, if it's not sure about the permission, for example, adding a new file to the directory or modify a file, it will always prioritize asking the user, do you want permit me to create a new file? Yes, or yes, and also directly give the access to every file in this directory, or the user can say no, and I will tell Claude what to do differently. Right, so basically, the design of Claude Code is make sure that the user is in full control of the permissions. So the user reviews the actions, the user approves or declines, and then the agent will behave correspondingly only if the user approve it. Okay, and then the fourth strategy is enable the extended thinking for complex problems. Even though the core principle is simplicity, but we also know that there are many tasks that require a deeper thinking, right? So they can be very simple tasks to implement, like just a single function with very well described inputs outputs, or it can be a pipeline that requires multi-step workflows, or it can be a very complex engineering problems such as architectural changes, right, that will impact lots of files. So basically, you can add additional thinking to the agent only if needed. Right? So for example, in terms of the architecture refactoring, you can say, oh, just analyze the current architecture first, identify what's the bottleneck, where to improve. design a new structure on top of the existing one, and then plan the migration strategies, and then outline all the incremental changes there, and then start execution. And also, Cloud Code also mentioned that recommend using the word think to trigger extended thinking mode. Just explicitly put think in the instruction, like think hard, or think harder, or ultra think, to really induce the reasoning capabilities, the thinking capabilities of the agent. But I also find a very interesting tweet. So I think this engineer used Cloud4 to refactor the Intel code base in one core. And he noticed like the 25 tool invocations, 3,000 plus new lines, and 12 new files. And also the agent is able to successfully modelize everything, and also clean up the spaghettis. But in the end, he also said like just during one call, none of it worked, but it's very beautiful. So I think this tweet is also interesting to show like if you just like give like a one call and just ask the agent to go well, like give it full permission, and then just ask it to do everything directly in one batch, it may not work. But I think in the end, the result or the code quality looks beautiful in the end. So that's why I also think the test-driven development will be important, right? So you need to still maintain a high bar of all the tests you put in order for the agents to make sure that it's still maintaining all the functionality and make sure that the codes are error-free. So that's the overall high-level mental model. And then let's look at the design, the like a feature of the Claude Code. So the core design is, of course, the agentic architecture, right? So the user provides the request via the command line interface. And then there's the AI agent using the Cloud 4 or 4.5 to reason, to plan, and then decide the actions to take. And then it's also able to access a set of tools on MCP, or you define the tool in the agent memory, and then give permissions to the agent to say, this is the tools, this is that you can access and use. And then by using all of this, with a plan, with a list of permitted tools, and then the agent will start generating codes to produce the codes for your requests. And the agentic loop in action. So usually I think this applies to any agent if you want to write, right? So the first is observe the environment, observe all the contexts you have, right? Like by the database or directories or like past use cases. And then you can read, for example, like read all the code base and the context, the documentations of the codes in the past, right? And observe to understand the current status of the directories. And then the agent should think, right? So explicitly ask the agent to think, just focus on thinking, to reason the problem, to figure out like, like in order to solve this problem, what data sets do I need to access? What tools do I need in order to solve this problem? And then the plan side is like after the thinking tokens, you may want to just outline the list of steps for the execution. And then the fourth is the act, right? Like just based on the plan, it's going to act each step with calling the tools. And then the fifth is the verify, right? So it's going to run the codes on the test that is predetermined and check the results to see whether the test pass or fail. And then it's going to refine the codes so that to make sure that all the tests can pass. And then there may be also some refactoring step, right, to make sure that the code is also as clean as possible and also stick to the coding style. And then the last is kind of like a repeat, because it's like a user interaction interface. So the user may ask additional requests, and then it's basically going to do all this loop all over again. So that's the overall agentic framework. And what makes the agent powerful is the agent memory. And then the memory actually can be managed by a file in your project directory. And then they call it Cloud Markdown file. And this is the ideal place for documenting everything you want the agent to know, right? Including what a set of bash command line the agent can run, about the core utility functions, about the coding style guidelines, testing instructions, repository relationship, the development environment setup, and all the warnings or specific problems or like a past experience you want the agent to familiarize. So basically, it's like all the prior context information you can kind of directly provide to the agent. And usually in the Cloud Markdown file, you can directly put it under your project here, or you can also put it into the subdirectories or the parent directories of the projects. So the AI will consistently remember your conventions and patterns across the entire project. So this is some example. So usually the Markdown format, in order for the AI to understand it, we also need to make sure that human is human readable, is also friendly to humans, right? For example, you can put it into several sections, such as this is a list of bash commands, right? So this is the commands you can run. This is the code style section, and this is the workflow. So the workflow is kind of like the prompt instructions to specific workflow that you want the agent to know. And then you can put this Markdown file in the root of your repositories, at a parent or child, or even the home folder. This is also interesting. Like if you put it in the home folder, this file, the agent is going to always use this as the base. It will going to apply to all your cloud sessions or all the agents. Because it's going to read from your home folder plus the root and plus the cloud Markdown file at your current directories. Cool. And then the third design is the tool access. So I think the bash tools are the most frequently used tools, so that you can do all the file manipulations. And also you can also collect Cloud Agent code with MCP by using this command like Cloud MCP add. For example, adding this Sentry MCP so that it can help monitor the error and debug the issues of the codes. And the user can also define your own prompt templates in the Cloud Commands folder. For example, so these are basically the prompts, right? The agent can keep reusing, for example, the fixed GitHub issues. And then this is the argument to the prompt templates, like it did directly pull, say, from the GitHub, and this is the GitHub issue descriptions. And then it's going to directly put into this prompt template. And then the agent is going, if it's related to the fixed GitHub issue, it's going to just reuse the same message as the instruction in the prompts, right? So this is kind of like, so that the agent don't need to rewrite the prompt over and over again, and which may not be the best. So you can just follow these steps, like list of instructions for the agent to execute the steps in order to resolve GitHub issues. Yeah, so the tool can be very like a file editor, terminal, browsers, and also version controls like Git commands over there. So even it's like all these tools over here, as I mentioned, right? Because the permission design is like the user has a full control. So you have the full control to give permissions to the agents. Like say you have all the permissions to the bash commands, or you have all the permissions to use any tool on this Sentry MCP. Etc. Or I permit the agent just to run every like a prompt templates under the command folder. So you can give, or you can just, if you feel safe, you can also give all the permissions in your current setup. So the agents can, like when it will ask for permission for certain, say, libraries or tools that you haven't given access to. The fourth design is also very impressive. I think it's a very interesting idea. It's the multimodal perception. Instead of focusing on requests only based on text in the command line interface, you can also directly input the a visual input to the Cloud Code. For example, the screenshots. For example, if you are going to create a website, right, and then you may have some website mockup, right, using the designer tool. And right now you can just take a screenshot of that website mockup, and then you pass that file, like a screenshot directly, like image file or like a link, the pass link to the image directly to Cloud Code. And then the Claude Code is going to write codes to generate the UI interface that match with the visual input. I think this is a very useful feature so it allows the rapid prototyping from the visual designs to the working codes, right? And then the visual designs as the input becomes also as the test case, right? Because when the agent is writing the codes and is going to execute the codes, and then it's going to compare the code output, for example, the visual output after execution to your original request to see, oh, what are the visual differences? What are the changes I need to match? For example, the colors or the style or the layout, so that the codes really can generate the website in your visual design. So this is quite kind of like the steps, right? So they design to you create a visual mockup and you pass it to the code, and then Cloud implements the UI, and then the Cloud Code also has a tool to basically do a screenshot, and then the agent can automatically do a screenshot of the web generated website, and then they can do the preview, right? And then they are going to compare the preview with the original mockup, and then to iteratively refine the codes so such as the final outcome exactly match or as close as possible to your initial design. I think this will be a great feature there, but I'm also reading tweets that this may not work very well currently. But I also see that the Claude Code is already expanding the engineers to 10. So I guess they are also investing to improve this feature so that it can connect it to the visual design. Okay, and then the fifth strategy is a multi-cloud. So I think this is more like a multi-agent strategy, right? Like put the LM, do not overwhelm the LM, but kind of split the task. For example, you can have a front-end cloud agent, just focus on the UI components, implement the design mockups, or handle the user interactions. And then you can also have another Cloud Code agent focus on backends. It's also like how we have front-end engineer, we have back-end engineers, so it's Cloud Code, right? So Cloud Code can also have front-end code and back-end code. And then back-end cloud will mainly focus on creating the APIs, design the database schemas, handle authentication, etc. And then the last design of Cloud Code is there are many different modes they specifically design so that the user can control, do you want the agent to just do everything full automatically, or you want the agent to do it in an interactive way so that the user has a way to intervene if they see anything divert, right? For example, they provide the option for the user to enable the headless mode. So headless mode is you can allow the agent to just run automatically without the interaction. For example, here it's like you kind of like do the Git or the version management, right? Just stage my changes and then write a set of commits. And then the allow tools, you can also to say in this full automation, this is a kind of list of tools that allow you to use. And then I also allow you to directly edit the file in the current directory, right? And then the agent is going to run full automatically without going back to you again. So this feature is very good for coding review, right? Just analyze the codes or analyze certain files, because the code is not just for coding. I think of it as more as your computer assistant. It's not just for analyzing codes, but you can also use it to analyze any files. Basically, whether it's a code file or it's like a log files or any other documentation you may have, right? So you can also use it for your log analysis. You can use it to automatically do the task verifications for the quality check. And of course, the documentation. So engineers usually complain that we don't have time for documentation. So I think here's a tool relatively, because I think the documentation is a lower risk. So you can use this tool to make sure that your documentation is also up to date. Yeah, so in summary, I think the principles they follow to enable a more effective human AI collaboration is especially for the user, right? So to provide specific instructions For example, if you want the agent to think hard, just explicitly say think hard to the agent, like make it very specific and explicit. And you should also share the rich context or prior domain knowledge about your project and goals in the Cloud Markdown file, right? And then the user should also provide active guidance and iterative feedback. And of course, define the success criteria by collaborate with agent to write up a set of tests for the development. And what the don'ts is the opposite side, like do not do like a one sentence request usually doesn't work. And like you may also miss the important context, and you like just watch passively, just like that example, right? The engineer just asked the Cloud Code to refactor his codes, although it looks beautiful, but it doesn't work in the end. So you still need proper guidance. You still need to help to develop that test in order to guide the agent effectively to make sure that the feature still maintained there. And the objectives needs to be very clear and defined. Yeah, so for Cloud Code, actually it's very easy to set up. And in the official website, they even claim that you can get started in 30 seconds. So, but there are some prerequisites that you may need to have some keys to give you access to cloud model, either using the Cloud AI to register account and so that you can have the keys there. And then you can just using this brew command, or like depending on what operating system you have, there's just a simple command. I also tried it on my laptop. It's truly just one command for you to just install the Cloud Code on your laptop. And then you can cd, so go to your project directories and then do the cloud command. And then you can already have access to the Cloud Code agent. Yeah. Okay. So this is also like how the users are actually using the Cloud Code. This is some summaries that the Anthropic published. This is what are the common workflows when they try with the Cloud Code. So the first is, of course, I think the code development. And I think the key is to focus on one task at a time, right? You just explicitly ask Cloud to read, just focus on read all the files, images, URL in the current directories, and explicitly tell it not to write any code yet. And then ask the Cloud to make a plan, right? And use the think harder, or alternate think to trigger a deeper thinking mode. And then you can ask it to implement the solution in the codes and also explicitly verify the solutions. If say all the tests are good, you can ask the code to commit the results. Always make sure you commit the results, because right now I think for the coding agent, sometimes it may say if you have a new ask, right, to add a new function, it may accidentally overwrite the codes and break the functions that have already been successful in the past. If you ever get something to work, make sure you commit the results, and then you can at least have a working copy from your past interactions. Yeah, I think this is a problem also that the LM is going to, or the agent needs to solve, to make sure that what has been implemented or what has been approved should not get modified or changed if the agent is working on a new irrelevant feature. And then the next common workflows I think people usually use is to prioritize writing tests first. Just ask Cloud to write the tests based on, you can provide it expected input and output pairs, which can be files, right? So this is the input file. This is the output results I'm expecting from this input. And then be explicit that you are doing a test-driven development. So this is a command you can directly provide to the cloud command line. And then after the tests are generated, and then you tell it to just run the tests. And it's important that ask the agent to confirm that they fail. At this moment, just ask the agent to verify that the tests fail, and do not let it to write any implementation at this stage. Sometimes this will be helpful, for the agent to really focus on, oh, I failed, and then to analyze why they fail, and then so that they can implement it better. And also ask the code to commit the test. Yeah, I think the best practice is always commit it once you are satisfied with it, no matter the tests or the codes. Make sure you always commit them. And then ask code to write the codes that pass the tests, and specifically mention that do not modify the tests. So this is very dangerous because sometimes the agent can, if there's some test that it cannot get past, it will modify the tests so that it will pass. So this will be dangerous, right? So just directly instructing it not to modify the tests. Or for example, you do not give the permission, the modification permission to every file in your test folder, and tell Cloud Agent to keep going until all tests passed. And then the third workflow is that multimodal design way. So this is a visual-driven workflow, right? So you can directly provide a screenshot, which can be images or just some path link to an image file. Or you just manually copy-paste screenshots into Cloud command. And then you can give Cloud a visual mockup. So just giving Cloud the image path. And then you ask Cloud to implement the design in the codes. And then if once the codes are there, execute the codes, and then do a preview and take the screenshots of the results and compare it with the design mockup, right? And then the Cloud will kind of just, if they notify, say the color is different or the layout is different, it's going to iterate until the results match the mock. The last step is always to commit if you are satisfied with current status. And the fourth workflow is for the Git management. I think this is a great helper, at least for me, is to, for example, search all the Git history, like what changes for this version and who owns this feature, etc., right, to understand the Git history. And you can also ask it to write the commit messages to summarize what are the major changes in the codes. And then it can automatically compose a message taking all the relevant context of the code changes or the new files in your directories. And then it can also handle the complex Git operations to, say, reword files or rebase the conflicts, etc. Yeah, so I think Cloud Code, even though it's called Cloud Code, but I think as long as you provided the right tools, I think it can do any system administration or your computer assistant to perform any task on your computer. Okay, I think the key takeaways is the simplicity beats complexity. I think Cloud Code is a great example to show how small teams can make a bigger impact with the right philosophy and with the right tools, right? So I think the Unix philosophy is powerful, right? The theme wrapper can deliver the transparency and predictability of the product. And this transparency actually will help build trust, because if you feel like you have the full control, you are going to gradually, the tool is also going to gradually gain trust with the users. And we have talked about the one core principle, the simplicity. We have talked about the 4 core strategies, the 6 core designs, and then the common workflows. And I think if you want to try out, I think it's a very easy setup, as I showed. And you can just go to the Cloud Code page and just follow like which operating system you are on. Just follow the command line. Like one command line, you have Cloud Code on your laptop, and then you can just start interacting with it and to see like how you can perform the any task on your laptop, on your computer for you. Yeah. I also want to end today's presentation with some outlook of agentic development. I think current state, like in the past 2 years till now, the coding agent can help the developers write code faster and maybe debug more efficiently, or help the developers to understand the code repositories faster through the Q&A process, right? But the developers will still remain in the full control of the codes. I also see complaints that the developers say the auto-generated codes, it takes them longer time to understand the codes right now rather than write the codes themselves. So yeah, so that's the current state. And if you look into the near future in the next 2 years, I think AI is going to become a true collaborative partner, and it may help handle some architectural decisions and then can do some multi-file refactorings if provided the right guidelines and instructions. The long-term vision, I think, for agentic development is the barrier to deliver software is going to be dissolved, right? So there is no barrier for anyone to develop a software. So anyone with an idea can create a sophisticated software. I already see the people already publishing apps or websites just using this vibe coding currently. Although maybe like it still takes them a long time to really converge into a good state. But I do see like in the longer term vision is anyone with an idea can create the software they want to have for themselves or for others, right? And then I think at that stage, the creativity, the human creativity and the design taste becomes the limit of what you can deliver.